minus 1 into x square plus a square minus 3a plus 2 into x plus a into a minus 1 is equal to 0 is satisfied by more than two values of x, then what must be a value? This is the question. So this kind of equation is satisfied by more than two values of x. So the concept behind this problem is this. Suppose when you consider ax plus b is equal to 0, then x value is equal to what? Minus b by a. So this equation is satisfied by only one value of x. If anybody says that it is satisfied by more than one value, then a must be 0, b must be 0. Then only it is possible. Otherwise it is impossible. Similarly, ax square plus bx plus c is equal to 0 usually satisfied by two values of x, which are minus b plus or minus square root of b square minus 4ac by 2a. Suppose in case it is satisfied by more than two values of x, then the condition is a must be 0, b must be 0, c must be 0. See, under these conditions, it becomes 0x square plus 0x plus 0 is equal to 0. So this is satisfied by what? In fact, infinitely many values of x. So in general, any nth degree equation like this, see, the general concept to remember is the following. a0 x power n, a1 x power n minus 1, a2 x power n minus 2 an is equal to 0 is satisfied by more than n values of x, implies a0 is equal to a1 is equal to a3 is equal to an is equal to 0. This is the concept. You should remember this. Under these circumstances, this becomes what? An identity in x. So, nth degree equation like this is satisfied by more than n values of x, implies it is satisfied by infinitely many values of x, and each coefficient must be 0. This is the important point to notice first. After knowing this point, then the problem is very simple. A square minus 1 must be 0. A square minus 3a plus 2 must be 0. A into a minus 1 is equal to 0. This will give you minus 1 or 1. This is 1 comma 2. This is 0 comma 1. The intersection of all these things is what? A must be equal to 1. So the intersection of all these things is nothing but what? A must be 1. See, this question sometimes you will get like this. A square minus 1 into x square, a square minus 3a plus 2 into x plus a into a minus 1 is equal to 0 is an identity in x. What must be the values of a? Means same thing you are supposed to do it. It is an identity in x means what? It is satisfied by infinitely many values of x. Then what are the values of a? Means you have to do the same thing, right? Now the next question is solve the equation a into b minus c x square, b into c minus x plus c into a minus b is equal to 0. Solve this quadratic equation. See, there is some sort of symmetry in this equation. If you observe, x square coefficient plus x coefficient plus constant, you will get 0. Watch. You recall one of the theorems what you have learned in 10th class level. If sum of the coefficients in any polynomial equation is 0, then 1 is a root of it. If sum of the coefficients of a polynomial equation is equal to 0, 1 is a root of that equation. If sum of the even powers of x is equal to sum of the odd powers of x, then minus 1 is a root of that equation. Here, sum of the coefficients is 0 means x is equal to 1 is a root, because sum of the coefficients is 0. Let other root be alpha. Consider product of roots. Alpha into 1 is equal to c into a minus b by a into b minus. So the other root is 1 for you, c into a minus b by a into b minus c and 1. These are the roots of this equation. Okay, understood? So solve this equation means you can do like this. The next point is, next question is, a into b minus c x square, b into c minus x plus c into a minus b is equal to 0 has equal roots. Then show that a, b, c are in HP. The equation is having equal roots. You have to show that a, b, c are in HP. So listen. Already by inspection, 1 is a root. Sum of the coefficients is 0 means 1 is a root. Since the equation is having equal roots, other root also must be 1. So what is the product of roots? C into a minus b by a into b minus c is 1. So AC minus BC is equal to AB minus AC you will get. So 2AC is equal to AB plus BC implies BC, AC, AB are in AB. Divide with ABC. 1 by A, 1 by B, 1 by C are in AB. Then reciprocals. A, B, C are in what? HP. So therefore, this quadratic equation is having equal roots means A, B, C are in HP. Yes, understood? Now, listen one more point here. Whenever this quadratic equation is having equal roots, this quadratic expression will become a perfect square. So when this corresponding quadratic equation is having equal roots, this quadratic expression will become a perfect square. So sometimes we come across a question like this. This expression is a perfect square. So this is a perfect square. Then A, B, C are in what? HP. So if it's a perfect square, corresponding quadratic equation will have equal roots. Then proceed like this, get A, B, C to be in HP like this. Understood? Right. The next question is, sum of roots of ax square plus bx plus c is equal to 0 is equal to sum of squares of sum of the squares of reciprocals of the roots. Then show that A by C, B by A, C by B or in H. So what is the question? Sum of the roots is equal to sum of the squares of their reciprocals. Sum of the squares of the reciprocals of roots of this equation. Right. Let us say roots are alpha and beta. Alpha plus beta minus b by a. Alpha beta is c by a. So what is given? Alpha plus beta is equal to 1 by alpha square plus 1 by beta square. Sum of the squares of their reciprocals. This is A1. Now, alpha plus beta is equal to alpha square plus beta square by alpha beta whole square. So, alpha beta whole square into alpha plus beta is equal to, this is alpha plus beta whole square minus 2 alpha beta. So this is c square by a square into minus b by a is equal to b square by a square minus 2c by a will get. You can cancel, I will write this separately here, a by c, b by a, c by a, like that. So you can cancel the root a, therefore you are going to get how much? Minus bc square by a is equal to minus bc square by a square is equal to b square by a minus 2c. Otherwise you take LCM as a, you get b square minus 2ac by a. 1a will cancel. Finally, what will get? Minus bc square is equal to b square a minus 2a square c. So, 2a square c is equal to b square a plus bc square. So, therefore, what you are going to get? bc square, a square c, b square a are in AP. Divide with ABC. Divide with ABC. You will get divided with ABC. When you divide with ABC, you are going to get C by A. Then this is A by B. This is what? B by C or in AB. So C by A by B, B by C are in AP means these are in what? HP. That's it. Okay? Right. Just the manipulation. Now, the next question is, alpha is a root of the equation 4x square plus 2x minus 1 is 0. Show that other root is 4 alpha cube minus 3 alpha. Alpha is the root of that equation. You have to show that other root of the equation is 4 alpha cube minus 3 alpha happens to be the other root of the equation. It is a manipulation problem, that's it. Alpha plus beta is equal to minus 1 by 2. Alpha beta is equal to minus 1 by 4. What is beta from this? Minus 1 by 2 minus alpha. Now, you observe this. Alpha should satisfy this equation, is it not? You will get like this. So from this, what is minus 1? 2 alpha minus 4 alpha square. Correct. So here you substitute 2 alpha minus 4 alpha square by 2 minus alpha. you will get what? Alpha minus 1 by 2. Minus 1 by 2 is minus 1 happens to be 2 alpha minus plus కదా, right. So you will get like this. So minus 2 alpha. So minus alpha minus 4 alpha square minus alpha. And this is what? Minus 4 alpha square minus 2 alpha you get. You take this equation, multiply with alpha. 4 alpha cube plus 2 alpha square minus alpha is 0. From this, what is 2 alpha square minus 4 alpha cube plus alpha? Correct. Okay. So 2 alpha square is equal to okay, because 4 by 2. So you substitute the 2 alpha square. You will get minus 4 alpha cube plus alpha minus 2 alpha, which is 4 alpha cube minus 2 alpha. So beta is equal to this. So if alpha is one root of the equation, the other root is what? In the form of 4 alpha cube minus 3 alpha. See, listen, one more point. The other root may be in this form also. Minus 2 alpha square minus 2 alpha. So usually in more than one choice question, you will get like this. Alpha is the root of this equation. The other root is. One choice is this, one choice is this, like that you will get options. Then you have to go on verifying all those choices. Right? Otherwise, you have to solve this equation and substitute in each one of them and see whether they are going to be the other root or not. Right? I think you are following this question. Okay? Right. The next question is, one root of a square minus 5a plus 3 into x square plus 3a minus 1 into x plus 2 is equal to 0 is twice the other. One root of the equation is twice the other. Find the value of a. One root of the equation is twice the other. Find the value of a. That is our next question. One root is twice the other. What is the values of a? Let alpha comma alpha 2 alpha. One root is twice the other. Alpha 2 alpha roots. Sum of the roots. 3 alpha is equal to 1 minus 3a by a square minus 5a plus 3. Product of roots. 2 alpha square is equal to 2 by a square minus 5a plus 3. You got like this. This alpha value you put here. 2 will cancel. 1 minus 3a whole square by 9 into a square minus 5a plus 3 whole square is equal to 1 by a square minus 5a plus 3. You will get like this. You can cancel one term. You send it to that side. Expand it. 9a square minus 6a plus 1 is equal to 9a square minus 45a plus 27. you can cancel like this. So if you bring it to this side, 39a is equal to how much? 26. A is equal to 2 by 3 units. A is equal to 2 by 3. That's it. A very, very simple question. The next question. Find the quadratic equations. Find the quadratic equations whose roots are unchanged. Whose roots are unchanged even after squaring them. Even after squaring them. So the quadratic equations whose roots are unchanged even after squaring the roots. That is our next question. So that means what? Let us consider one quadratic equation like this. X square plus ax plus b is equal to 0. Let us say alpha and beta are roots. We square it. Alpha square, beta square. Alpha beta is as good as alpha square comma beta square. See, does not mean that alpha square is alpha, beta square is beta. Alpha square may be beta. Beta square may be alpha. Like that, anything is possible, right? So, like that, how many quadratic equations are there? Here it is understood that alpha and beta are what? Real. And the quadratic equation is having real coefficients. That is also understood. So, see, whenever you want to consider a quadratic equation, it is not necessary that you should always consider ax square plus bx plus c is equal to 0. You can as well consider this. Because quadratic equation means a not equal to 0. Even if you consider a square plus bx plus c is equal to 0, since a not equal to 0, you can divide throughout with a. B by a is what? Once again, one constant, c by a is constant, therefore it becomes in this form. So consider a quadratic equation means it is always better to consider like this. Let us say alpha comma beta are roots. Then what is alpha plus beta? Minus a. Alpha beta is equal to what? B. Now, you form a quadratic equation whose roots are alpha square comma beta square. What is the quadratic equation whose roots are alpha square and beta square? It is x square minus alpha square plus beta square into x plus alpha beta whole square is equal to 0. This is the quadratic equation whose roots are alpha square and beta square. What is alpha square plus beta square? Alpha plus beta whole square minus 2 alpha beta, which is a square minus 2b. So this equation will be x square minus a square minus 2b into x plus this is b square is equal to 0. So listen, for this equation alpha and beta are roots. For this equation alpha square and beta square are roots. Alpha beta is as good as alpha square beta square. That means this equation are having same set of roots. Whenever two quadratic equations are having same set of roots, what I said, their coefficients are in proportion. Whenever two quadratic equations are having same set of roots, their coefficients are in proportion. So this is one equation. The other equation is minus a square minus 2b into x plus b square is equal to 0. These two equations are having same set of roots, therefore 1 by 1 is equal to a by 2b minus a square is equal to b by b square. See, whenever you come across like this, you should not blindly cancel b square. If you cancel like that, you will be missing one of the solutions. First, you should cross multiply these two. You will get b square is equal to b, implies b is equal to 0 or 1. Right? Next, this is a is equal to 2b minus a square plus a minus 2b is equal to 0. Now, first consider b 0. Then you will get a square plus a 0. That is a is equal to 0 or minus 1. So, b0 a0 means x square is 0. b0 a minus 1 means x square minus x is equal to 0. Okay, right. Next, consider b is equal to 1. Then you are going to get a square plus a minus 2 is equal to 0. So this is a is minus 2 or 1. B is 1. A is minus 2. Means x square minus 2x plus 1 0. Next you are having x square plus x plus 1 is equal to 0. Right? So this is number 1, number 2, number 3, number 4. What are roots of this? 0 and 0. Roots of this are what? 0 and 1. Roots of this are what? 1 and 1. See, in complex numbers, you will be knowing this. The roots of this are omega and omega square, where omega is complex cube root of unity. See, if you square this, you will get omega square. Omega square whole square is omega power 4, which is as good as omega. That you will be learning in complex numbers. When you have to do one thing, you solve this equation, you will get complex roots, observe them. You square one of them, you will get the other. Like that, you are having what? There are 4 such equations, such that the roots of that quadratic equation will be unchanged even after squaring them. Understood? Similarly, you can have one more question. The quadratic equations whose roots are unchanged even after cubing them. That is our next question. You can try that question like this. Your answer is 7 for that. You should get 7 such equations. You read on this question. Alpha comma beta are roots of the equation x square plus x sin theta, x square plus x sin theta minus 2 sin theta is equal to 0. Theta belongs to 0 to pi by 2. Theta is in the first quadrant. Then the value of alpha power 12 plus beta power 12 by alpha power minus 12 plus beta power minus 12 into alpha minus beta whole power 24. Alpha minus beta whole power 24 is equal to how much? This is our next question. It's a very simple question. Alpha plus beta is equal to minus sin theta. Alpha beta is equal to minus 2 sin theta you want. Now you take this. This is alpha power 12, beta power 12. This is 1 by alpha power 12, 1 by beta power 12. So which is as good as alpha power 12, beta power 12 by alpha beta whole power 12. into alpha minus beta whole power 20 is the okay, right? You have got like this. Okay, understood? This is as good as 1 by alpha minus beta by alpha square beta square whole to the power of, otherwise you can write like this, alpha beta whole square by alpha beta whole power 12 I will write. Okay, this is alpha minus beta whole square whole power 12 by alpha beta like this. What is alpha minus beta whole square? Alpha plus beta whole square minus 4 alpha beta. That is 2 sin squared theta plus 8 sin theta. What is alpha beta? Minus 2 sin theta. You substitute 1 by sin squared theta plus 8 sin theta by minus 2 sin theta whole power 12. Since whole power even number is there, this minus sign I can remove. So I am going to get how much from this? Sin theta plus 8. So 1 by 2. So you get 2 you can send above. 2 power 12 by sin theta plus 8 whole power 12. This is what you are going to get. So it is a very simple question. This is one of your mains questions. See, mains questions will be usually very simple like this. The next question is 2 plus root 3 is a root of 2 plus root 3 is a root of the equation x square plus px plus q is equal to 0, where p comma q belongs to R. P and q are real numbers. Then find the values of p and q. Find the values of p and q. See, yesterday I said this point. If a alpha plus root beta is a root, alpha minus root beta is also a root. So, the roots of this equation are 2 plus root 3, 2 minus root 3. Sum of the roots, 4 is equal to minus 3. Product of roots, 4 minus 9 is equal to q. So, p is equal to minus 4, q is equal to minus 5 units, which is also one of your main questions. Next question. Find equation with real coefficients. Real coefficients having lowest degree. And one root is root 3 plus root. Equation with real coefficients with lowest degree having one root as what? Root 3 plus root 2. See, yesterday I said if one root is this, automatically root 3 minus root 2 minus root 3 plus root 2 minus root 3 minus root 2. This is of course root 3 plus root 2. They are all what roots? So the minimum degree must be what? 4. Understood? Now you do one thing. You club these two and form quadratics. When I club these two, x square minus this plus this is what? 0x. Plus this into this. This into this is how much for you? Otherwise, you would do one thing. Stop this. Okay, okay, let's do one thing. Do one thing. You take. Okay, right. This also you can consider. That's no problem. Okay, these two only you consider. Get x square minus 0x plus, minus root 3 plus root 2 whole square. Okay, understood? Now, you consider these two as one set. X square, this plus this is what? 0x. This into this you consider. See, this into this means you can write minus root 3 minus root 2 whole square is 0. So I am considering a quadratic equation formed by these two. A quadratic equation formed by these two like this. Now, when I multiply this, I will get what? X power 4. X power 4, right? Minus, see, x square 0x is there, x power 4 first I am going to get. Then next what I am going to get? X square into this, x square into this means minus root 3 plus root 2 whole square plus root 3 minus root 2 whole square into x square. Plus what? Product of course. Root 3 plus root 2 whole square into root 3 minus root 2 whole square is 0. See, x power 4, 0x. So, x square into this. X square into this means this. And then finally what? This into this. So, this is x power 4 minus x square into, it's just like what? A plus b whole square plus a minus b whole square. This is 2 into a square plus b square. My plus this into this means what? A plus b into a minus b form. So 3 minus 2 whole square. So finally x power 4 minus 10x square plus 1 is equal to 0. X square, x power 4 minus 10x square plus 1 is equal to 0, you are going to get. So a polynomial equation with real coefficients with least degree having one root as this means automatically these three are also roots. Then find that equation means you consider these two roots and form a quadratic. Consider these two as roots and form a quadratic and multiply them. Then finally if you simplify properly you will get like this. You read on this. M is such that the sum of roots of the equation m square plus 1 into x square minus 3x plus m square plus 1 whole square is greatest. Sum of the roots of this equation is greatest. Find absolute difference between cubes of roots of the equation. Absolute difference between the cubes of the roots of the equation. That is our next question. See, m is such that sum of the roots is greatest. Then what is absolute difference between the cubes of roots of the equation? What is sum of the roots? Alpha plus beta is equal to 3 by m square plus 1. See, m square is always greater than or equal to 0. So, when does this is maximum? When m square is minimum. What is minimum value of m square? 0. So, alpha plus beta maxima implies m should be 0. Alpha plus beta maxima means m must be 0. When once m is 0, what is your quadratic equation? X square minus 3x plus 1 is equal to 0. You require mod of alpha cube minus beta cube. For that, alpha plus beta is what? 3. Alpha beta is 1. You know a cube minus b cube factorization. Alpha cube minus beta cube is alpha minus beta into alpha square plus alpha beta plus beta square. Right? What is alpha minus beta? Square root of alpha plus beta whole square minus 4 alpha. What is alpha square plus beta square? Alpha plus beta whole square minus 2 alpha beta plus alpha beta. So alpha cube minus beta cube factorization is this. So this is mod of. Substitute in this. Square root of 9 minus 4 into 9 minus alpha beta means what? 9 minus. So finally this is what? 8 root 5. That's it. Okay, understood? Yes, I think you are following. Next question is the equations x square plus 6x plus 8 is equal to 0, x square plus kx plus 4 is equal to 0 are having a common root. Find possible values of k. The two equations are having a common root. What are possible values of k? See, when you come across like this, I advise you to think like this. First, you take this equation. This you can easily solve it. This is as good as what? X plus 2 into x plus 4 is equal to 0. X is minus 2 comma minus 4. So minus 2 may be common or minus 4 may be common. If minus 2 is a common root, substitute 4 minus 2k plus 4 is equal to 0, k is equal to 4. If minus 4 is a common root, then 16 minus 4k plus 4 is equal to 0, k is equal to what? 5. You can do like that. You need not apply the theory what I taught for common roots. You can directly do the problem like this. The next question is A, B, C are sides of a triangle. A, B, C are sides of a triangle. Right, integer sides of a triangle. A, B, C are positive integers, right? Positive integers and sides of a triangle. Ax square plus bx plus c is equal to 0. 3x square is 4x square plus 3x plus 5 is equal to 0 are having one root common. One root common. Then find minimum area of the triangle. Minimum area of triangle. Formed by ABC. Minimum area of triangle formed by ABC. Right. Now listen to me. See, if you observe this equation has no real roots. This equation is having what? Complex roots. So, if one root is common for both of them, other root is also automatically common. So, whenever you come across a question like this, two equations, one of the equations you will be knowing that its delta is less than 0. If delta is less than 0, it will not have real roots, it will have complex roots. So in complex numbers you will be knowing about this. Complex roots always come in pairs. So if there is a complex root, then its conjugate is also a root of that equation, provided the coefficients are what? Real. Your coefficients are anyhow what? Real for you. So since the second equation's delta is less than 0, if one root is common, other root is also common. Which implies what? The two equations are having same roots. So a by 4 is equal to b by 3 is equal to c by 5. So delta observe it. 4 b square minus 4 is observe it. Now a, b, c are what? Positive integers. So minimum values of a, b, c are what? A is 4, b is 3, c is 5. 3, 4, 5 are what? Pythagoras numbers. So therefore, this is 5, this is C, capital C, this is 4, this is capital A, this is what? 3, this is what? Capital B. So what is the area of triangle? 6. Minimum area of the triangle formed by them is what? 6 for you. Yes, so what I want to remember is, if you come across two equations like this, having a common root means if the other equation's delta is less than 0, you take it granted that they cannot have only one root common. They will have both roots common. So when both roots are common, what is the condition? You all of you know, you can apply that and get the answer. Right. So the next question is, alpha comma beta are roots of the equation x square minus 6x minus 2 is equal to 0. Alpha and beta are roots of this equation. A n is equal to alpha power n minus beta power n greater than or equal to 1. Then the value of A10 minus 2A8 whole divided by 2A9. Find the value of this. Alpha and beta are roots of this equation. You are supposed to calculate that. See, alpha is the root of it. So, alpha square minus 6 alpha minus 2 0. Minus 2 is 0. See, the roots of that equation cannot be zeros. Means alpha cannot be 0. So, I want what A10 means what? Alpha power 10 minus beta power 10. I will multiply with alpha power 8. Multiply with alpha power 8. So alpha power 10 minus 6 alpha power 9 minus 2 alpha power 8 is 0. Similarly, beta is the root of it. So you will get beta power 10 6 beta power 9 minus 2 beta whole power 8 is 0 you get. Yes, understood? Now, an is what? Alpha power n minus beta power n. Subtract. Alpha power 10 minus beta power 10 minus 6 into alpha power 9 minus beta power 9 minus 2 into alpha power 8 minus beta power 8 is 0. So this is A10 minus 6 A9 minus 2 A8 is equal to 0. Now you require what is A10 minus 2 A8 is equal to 6 A9. So A10 minus 2 A8 by 2 A9 is equal to how much? 3. Yes, understood? This is what you are supposed to do it. This is also one of previous mains questions. For a positive integer n, x into x plus 1 into x plus 2 etc. x plus n is equal to 10n has two consecutive this is not correct. Let's correct it. For a positive integer n, the quadratic equation like this: x into x plus 1 plus x plus 1 into x plus 2 etc. x plus n minus 1 into x plus n is equal to 10n has two roots, two consecutive integral roots, integral solutions. Then the values of n. What are the values of n? It has two consecutive integral solutions. What are the values of n? So listen, this is just like what? X plus 0. So 0 up to n minus 1 means n terms. So there will be n x squares. Then what about x coefficients you are going to get? Plus x into, here what? 1 plus 0, 1 plus 2, 3 means 1 plus 3 plus 5 up to 2n minus. Then you are going to get here what? You are going to get 0 into 1, 1 into 2, next to 2 into 3, etc. n minus 1 into n is equal to 10. So this is nx square plus sum of odd consecutive positive integers up to n numbers is what? N square. You have to know this. Recently I taught nx square into x. This summation, I think you have to know how to calculate. Sigma r minus 1 into r. R value ranges 1 to n. How much? Sigma r square. Okay, r n into n plus 1 into 2n plus 1 by 6 minus n into n plus 1 by 2. So if you simplify this, n into n plus 1 by 2, 2n plus 1 by 3 minus 1. So n into n plus 1 by 2, 2 into n minus 1 by 3. This two will cancel. So you will be left with what? N into n square minus 1 by 3 minus 10n is 0. Simplify this. The summation of this, you know how to calculate the summation, you will write like this. Okay, understood? After getting this, what he says, you can cancel throughout n. You can cancel throughout n like this. So this is the equation you are having. If alpha and beta are roots, what is mod alpha minus beta 1? Because two consecutive integer roots means the difference between them is what? 1. So mod alpha minus beta whole square is also 1. So this is alpha plus beta whole square minus 4 alpha beta is 1. So n square minus 4 into n square minus 1 minus 30 by 3 is equal to 1. So what will get? 3n square minus 4n square minus the plus 124 is equal to 3. So n square is equal to how much? 121. N is equal to how much? 11. This is n square. Calculate this. Bring everything onto one side. This equation is having what? Two consecutive integers as its roots. So difference between them is what? 1. So estimate like this and try to complete the problem. Okay? Understood? The next question is, find all roots of the equation x square minus 5x plus 5 whole to the power of x square plus 4x minus 16 is equal to 1. See, whenever you come across this type of equations, you have to think like this. See, the first case is anything to the power of 0 is 1 except what? This should not be equal to 0. So x square minus 5x plus 5 not equal to 0. X square plus 4x minus 16 is equal to 0. Any number to the power of 0 is always what? 1. So this is your first case. You solve this. You will get what? X is equal to minus 10 and x is equal to what? 6. You ask a question. If I put minus 10 here, is it going to become 0? No. 100 minus 50. So it can't be 0. You put x is equal to 10. If I put x is equal to minus 10, x square minus 5x plus 5 not 0. X is equal to 6. X square minus 5x plus 5 is not 0. So these two are solutions. This is our case 1. Next, consider case 2. X square minus 5x plus 5 is equal to 1. So this is equivalent to 1. 1 power anything is what? 1 only. So this may be anything. Now consider this 1. Then you will get what? X square minus 5x plus 4 is 0. X is equal to 1 comma 4. So this is your solution. Right? Next is case number 3. Case number 3 is what? This is equal to minus 1 And for those values of x, this is even. This is even. So x square minus 5x plus 5 is equal to minus 1, and x square plus 4x minus 6 is what? Even integer. This should be even integer. See, minus 1 whole square, minus 1 whole power 4, like that. When you solve this, what will you get? X square minus 5x plus 6 is 0. X is equal to 2 comma 3 you get. You take this. X is equal to 2 means what will you get? 4 plus 8 minus 6. So even. So x is equal to 2 source. X is equal to 3 you put. You will get what? 9 plus 12 minus 6, which is what? Odd. Therefore 3 fails. Right? 3 fails. So finally what are your solutions? X is equal to 1, 4, next 6, minus 10, number 8, 2. These are your solutions. Then the question what you got in the previous mains, one of the mains examination is the total sum of roots of that equation. What is the total sum of roots of this equation? 5 plus 6, 11, 11 minus 10 is 1, 1 plus 2, 3. So total sum of roots happens to be 3. Okay, understood? So whenever you come across a question like this, you should consider cases. This is equal to, this is not 0. This is a non-zero number. Any non-zero number whole power 0 is always 1. Any non-zero number whole power 0 is always what? 1. Non-zero, 0. You got this. Now you should verify. For minus 10 and 6 is going to become 0 or not. So fortunately it is not 0. Therefore minus 10 and 6 are what? Roots of that equation. The next consider this should be 1. 1 power anything is 0. Except what? Infinity, of course. So infinity will not consider anyhow. So this is equal to 1 means you got what? 1 and 4. So 1 and 4 are definitely roots for you. Next to consider this is equal to minus 1. When this is minus 1, this should be what? Even integer. When this is minus 1, this should be even integer. That's what I wrote. This is minus 1 and this is what? Even integer. So this is minus 1 means you will get like this. You got 2 and 3. Then for 2 and 3 verify whether this is going to become even integer or not. For 2 it becomes even integer. For 3 it becomes what? Odd integer. Therefore 2 is the only root of that equation. Then finally sum up. You got all these values as roots. Then sum of the roots is the one of the main question. That's why I asked you to calculate sum of the roots. Sum of the roots is equivalent to 3. You got it. Okay, understood? Right.